Welcome everyone to FabFems Friday today with a focus on mechanical engineering. We have a fabulous lineup through July, and we've been holding these every week with a different major every week. So it's been really fun getting to learn about them. I'm Sarah Dolby. I work for UTWEP. I'm an architectural engineering major. So I'm not mechanical, but I'm here to help facilitate and help out here. So today we have a bunch of fabulous panelists, and you can find more about them on the FabFems national database. So it has a lot of women in science, technology, engineering, math, STEM, and there's lots of role models there, and you can check that out. And you can sort by zip code, their field of work, their ethnicity, interest of engineering, and everything like that. So that's a really cool resource for y'all to check out. So let's get into the introductions. So whenever y'all introduce yourselves, if you would mind giving your name, pronouns, hometown, what your major is or was, your year in school or your company, what you do outside of school or outside of work. So let's start with Leah.
Hi everyone, my name is Leah. I go by she, her pronouns, and I'm from Austin, Texas. I'm an incoming sophomore in mechanical engineering. And outside of school, I like to paint with watercolors, bake, and read for fun.
Dr. Supersad, sorry.
You got it. That's good. Hi, I'm Carolyn Prasad. I'm a professor of mechanical engineering. I've been here for quite a while, about 15 years at the university. So I specialize in engineering design and additive manufacturing or 3D printing. And so I teach classes in those areas, also do research. I'm also the director of a new center for additive manufacturing and design innovation that we just launched a few months ago. What else can I tell you about myself? I'm originally from West Virginia. So I went to undergrad at West Virginia University. So originally a Mountaineer in blue and gold, but you can see that I am rocking the burnt orange today. So no worries there. And then earned my PhD in mechanical engineering from Georgia Tech. And I've been here in Austin ever since. Let's see, what else can I tell you about myself? When I'm not at work, I enjoy spending time with my family. I have 2 kids, a husband and 2 kids. One who's about to turn 13 on Sunday, which scares me just a little bit, and a dog, a greyhound puppy. And then we like to do lots of things. I love to cook, and we 3D print even at home. If I can rotate my camera around, you might even be able to see one sitting over there on the side, kind of, sort of. So anyway, yeah, that's a little bit about me.
Awesome. Thank you so much, Dr. Supersad. We actually haven't had a faculty member yet this summer, so I'm really excited for that. All right, Ms. Walker.
Hello, everyone. My name is Joya Walker. I am in Houston, Texas. I work for DuPont in the reliability consulting capacity for North America. So I'm an internal consultant. My background is in mechanical engineering. So I am originally from Louisiana. I tell people that it's a small town that does not have a Target or a Starbucks, but it's very family oriented. So I'm close to my family, and aside from enjoying time with family and friends, I'm a professional singer. So I sing gospel music, and I'm actually going to be featured on an album in the near future. And also I would say that I like to travel, shop, and bake.
Awesome. Rebecca, I know you just joined, but we're just doing introductions. So if you want to give your name, pronouns, hometown, your major, and your year, and then whatever hobbies you do outside of school.
Yeah, first of all, sorry for the delay. My name is Rebecca. I'm going to be a 4th year at UT. My pronouns are she, her, hers, and my hometown was actually Gurnee, Illinois. But I currently live in Austin. And hobbies, I play a lot of piano. I try my best to keep up with it despite school. And I love just working in student organizations. I'm with Leah in officer board for Women in Mechanical Engineering, which y'all should check out later. But yeah, that's a little bit about me.
Awesome. Thank you all so much for introducing yourselves and for being here. Okay, so we're going to get into our pre-selected questions first. So the first one is for Dr. Seepersad and Joya. So what made you decide to pursue mechanical engineering? And can you share a bit about your work in the field? Maybe like a project you've worked on, or your favorite thing that you've gotten to be involved with as a mechanical engineer?
Sure, I can go first. So I picked mechanical engineering for a few reasons. First, I wanted to choose a field that I could hit the ground running after 4 years. I did love science, both science and math. And it was pretty much between engineering and computer science. Because of my work ethic and personality, I decided that engineering would allow me the experience to be able to work with people for team building and collaboration, as well as solely if I wanted to. And then the discipline of mechanical engineering I chose because of the options. So I'm the type of person that once I am able to become a subject matter expert in something, I would like to explore something else. I kind of get bored easily. And I saw those options more available to me in the mechanical engineering discipline. So for example, in my current role, you asked about a current project or example that we've worked on. And as an internal consultant, I've been able to work on a vast projects, which is a love and hate relationship I have with it so far. So with that, I'm always learning. So for example, we had a kickoff of a special assignment where we had different sites, different plant manufacturing locations that were in high demand, that were sold out in product, and they needed to increase their productivity. So they needed to increase the amount of production of those products that they made and sold. And so part of my assignment was to be the reliability leader, to go to the facility to understand where they currently were, to be able to communicate industry best practices in regard to reliability and maintenance, and then to assess the resources that were available at the site, assess their knowledge, the culture, and then develop a plan that would be from short term, 3 to 6 months, to long term that would span from 18 months to 5 years. And so one of my projects, I worked with the Pioneer site, this agriculture site, where they developed corn seeds, and a sewing machine was a part of that process to develop corn seeds for them. And it was a bad actor. So that sewing machine was not, it wasn't operating correctly in regard to asset utilization. And so we took a team, we did a root cause analysis, did some failure mode and effect analysis to understand those defects. We increased production by 50% at that site, and they were able to meet their production goals in that. And I share that example because I didn't know much about their process at all. And so it put me back into the study and research process like we do, in school, to understand you're being exposed to a new process, but those principles are able to be applied from beginning to end. And we're so excited when we're able to see results in engineering because we're problem solvers.
Good, great. So I think the question was two-part, right? One was how we got into mechanical engineering. Another was an example of something cool we had done. And I think it was La Joya who mentioned that there was no Target in her hometown. And so I'm in a similar position. I like to tell people that when I was young, I would measure how rural you were by how long it took you to get to the nearest McDonald's, right? And for me growing up, that was an hour. So think about how McDonald's is now like your whole Saturday activity, right? Just going to McDonald's. It kind of was. So growing up in very rural West Virginia, I didn't actually have any engineering role models. In fact, I don't recall knowing anyone who was an engineer growing up. I had great teachers in a great school system. Despite, you know, being so rural, we actually had an excellent school system, and I loved math and science. And it was clear to me that I really wanted to apply it as opposed to just being sort of a pure mathematician or just a pure scientist. So I was the type of kid who would go into the garage and say, hey, Dad, I'm going to build a boat and go test it out in the creek. And, you know, when it rolls over and it doesn't work, I'm going to come back and we're going to work on it some more, right? We're going to add some more pieces and we're going to make it better. And so, you know, that combination of really loving math and science and kind of loving how things work and making things really led me to engineering. And then when I got to undergrad at West Virginia University, it was time to choose what type of engineer. And I'd always been fascinated with space at the time, thought that was really cool. My dad was a career Air Force person before he retired to West Virginia. So I loved everything space and flight. But I didn't really want to be that specific because I learned that even in the aerospace industry, 90% of the people in aerospace are actually mechanical engineers. And so I said, well, you know, I might want to do a lot of other things too. And so let's not close those options. And so I really just thought mechanical engineering was this hands-on, tangible thing that would help me, you know, apply all that math and science that I really liked, and then work with people and be collaborative and those sorts of things. So it turned out to be a really good choice for me. I love mechanical engineering. I really wouldn't want to do anything else. In terms of cool applications, there's a lot of them, but as a professor, mostly it's my students who get to do the cool stuff. And so, you know, one of my, you know, some of my proudest accomplishments actually are all the students that I've had and what they're going out there and doing. But one example of a research project that we had that was really cool is we designed some new energy absorbing honeycomb materials and that was a really cool project. And those materials are useful for all sorts of things. They could be useful for protecting sensitive equipment, so you don't have to over design it quite so much. It could also be useful for personal protection. So we've looked into how I could use them in football helmets or other types of helmets. We have a student right now looking into whether or not they might make better energy absorption systems for the bottoms of prosthetic feet. So those types of things are really cool. That's a really cool application.
Awesome. Okay, so our next question is for Rebecca and Leah. What made you decide to pursue mechanical engineering? And can you share a bit about any projects or work experience you had while in school, or maybe like a favorite class if you haven't really had any relevant work experience yet? I know I haven't, so yeah, whoever wants to go.
Yeah, I can start. So I'll tackle projects and stuff first. I have kind of made it a goal to get exposed to as many fields as possible within mechanical engineering during my time at UT, which they do a fantastic job of helping us do so. We have these career gateway tracks in the mechanical engineering department, and there is a whole range of things you can apply to. If you are more interested in the biomechanical side of things, there's a track for you. Robotics and mechatronics, also there. So there's already a pre-established way to get involved into any of these, and classes categorized by that. But also there's so many student organizations and project opportunities. If you talk to people, if you just hear about like this professor working on different interests that you might have, and you go directly to them, email them, they're always more than happy to do so. I started out with my research opportunities with FIRE, the freshman research experience that Dr. C. Prasad actually leads. And that's where I got exposed to nanotechnology. And I ended up taking a nanotechnology course actually just this past May. So it can take you a lot of places. And as for what made me decide to pursue mechanical engineering, it would definitely have to be my love for design. That's what I started out with. Before coming to UT, I knew I wanted to do design of some sort, and I wanted to get my hands dirty and build things physically. I wanted to see the entire design process from beginning of just like creating ideas all the way to the end of actually seeing it be in use and help people. So that's what made me decide mechanical engineering.
Yeah, I'll be honest, I feel like I didn't know that I was going into mechanical engineering until I sent in my application to UT saying I was going into mechanical engineering. But it did start from a place of knowing that I want to be working on things around sustainability in the future, and that I really enjoyed math and science. But I, again, as many of these people have said, like, it's a pretty broad field. I didn't want to box myself in. And so putting all those things together really just led me to mechanical engineering. And then I've only been here a year, but I've already feel like I've gotten so much awesome experience. I was also in Dr. Supersad's class, where I got to work on a project converting natural gas to ammonia to be used for fertilizer. And that was super awesome, as well as just being involved in organizations. I got involved in a negative emissions technology organization and have gotten to do research with them. And just really, like, even in a virtual experience, like being able to throw myself into all these things and has really made me feel like a college student and has made me really excited to be part of mechanical engineering.
Awesome. Thank you all for sharing. The next question is for Dr. Supersad. Mechanical engineers work on all kinds of things. Can you share a little bit about some different projects or research that's going on currently with the mechanical engineering faculty? And then that helps kind of our participants get a feel for how broad mechanical engineering can be.
Yeah, sure. That's a great question. So I think someone, it might have been Rebecca, just talked about how we have in mechanical engineering different areas within our department, and they kind of help represent, I think, the breadth of things that we do. So let me do my best to give a sampling of some of those projects. So I actually sit in the area of manufacturing and design. And so my colleagues and I really focus a lot on improving the process of design. So getting from, this is what we need, these are our requirements, to what does this product or this system look like? A lot of work on manufacturing, like new 3D printing processes and things like that. But there are many other areas of mechanical engineering. And so one area we have in our department that I think is really cool is biomechanics. And so we have professors there who are working on things like new prosthetics, new ways to make prosthetics, smarter prosthetics. We have a robotics area that's within our, we call it dynamic systems and controls, but a lot of it is robotics. And so there's a ton of really cool projects there. There's one that's one of my favorites. Dr. Ashish Deshpande, who's one of our professors, has developed an exoskeleton called Harmony that can help with rehabilitation of stroke victims and things like that. So you can really look it up. It's really cool. It's like basically a robot that encompasses your arms and your upper body, and it leads you through different exercises, and it can assess your range of motion, and it can help you improve your range of motion and things like that. It's super cool. And then we have professors in what we call our thermal fluid systems area. So thermal fluid systems means that mechanical engineers also study fluid flow. So anything that has heat or airflow or liquid flow associated with it. So traditionally that's been combustion engines, right? And we do have one or two faculty who do work in combustion engines, but that's quickly changed. And so we now have folks in that area who do things like working on, I think it was Leah who mentioned, extracting ammonia from the effluent of processes, from looking at reducing friction around things. So that can make all of the systems that we use in our production systems much more efficient. What else we have? We have materials within mechanical engineering as well. And we have a wide variety of activities going on there. But I think one of the most famous ones within our materials area is our work in battery technology. So one of our professors, John Goodenough, just won the Nobel Prize a year or two ago for his work in inventing the lithium-ion battery. And so we have a whole handful of faculty members who work in that space. I think we're just setting up a new center, and they're interested in all sorts of things. What's the chemistry of the batteries, right? How to make them more efficient and more compact, how to reduce dependence on really critical but rare resources that are hard to find. I mean, do we have enough platinum in the world to make enough lithium-ion batteries to store all the energy that we need? The answer is probably not. We need to change the chemistry. We even have someone, Dr. Ezekoya, who looks at fire science, and in particular with reference to batteries. So you may have heard about lithium-ion batteries catching on fire sometimes, and that's an issue on aircraft particularly. What if we wanted to do electric planes, right? But we wanted to use lithium-ion batteries. What if there's some damage to them and we have a fire incident? So thinking about those types of issues. There's just so many things, right? You may not have thought that mechanical engineers do this. It used to be people, mechanical engineers, well, where's your overalls? Where's all the grease, right? And I think I just gave you a ton of examples, and almost none of them involved grease and overalls, right? So it's a really different sort of 21st century idea, I think, of what a mechanical engineer does. And it's really cool.
Awesome. Yeah, thank you for sharing. That is a lot, lots of options. Y'all should definitely look into that. Jane sent a link in the chat that kind of explains the career gateway options, and then also a link to a YouTube video about the Harmony robot bodysuit thing that Dr. Seepersad mentioned. So definitely check that out. All right, our next question is for Joya. So you work for a large company that employs lots of engineers, some mechanical, some from different disciplines. Can you talk about like the other types of work that a mechanical engineer can do within the company, and then how you interact with the different kinds of engineers and different scientists across the company?
Sure. So as we've mentioned before, there are so many different opportunities. So I'll touch on just a few groups that I've been blessed to work with or work in the capacity of. So one aspect would be design. And so in design, we would also encompass resources that would be material specialist, mechanical background. We would also work with resources who were engineers. So with that in aspect, we want to make sure that in the design phase, we are taking into consideration the chemical side for the process, the products that are running through the assets, and then how visible and attainable is it to maintain that equipment. So for example, I worked at a site where the design team developed this color coding system as a part of the process. And so when they designed it, they had this genius idea that would be highly effective in regard to increasing productivity. However, the design team did not take into consideration that someone would have to physically climb to get to the equipment in order to maintain it. So that is the reason that we include a vast majority of resources that are engineers with different aspects and different areas of contribution in the design phase. I would also say that we have subject matter experts that along the way in their technical journey, they decided to be an expert on maybe relief valve calculations or on heat exchangers, for example. And so they've spent several years of study, several years of failure analysis, physical failure analysis. And so from those experiences, they've been able to contribute to root cause analysis that different sites have or experienced on site. Another aspect would be the safety perspective. So I've been on teams where we've worked in regard to work that was generated from the CSB as well as OSHA. And so from a safety perspective, there are mechanical principles that are integrated within that work to help mitigate strategies, to help correct things that have taken place for events that were not positive. And so to try to turn around those events to a positive perspective to mitigate those things from happening in the future. So that's also another aspect. I would say that there are also things outside of the technical space that I've seen mechanical engineers contribute to within the company. So that could be in training, for example. So I've done several trainings in regard to best practices, in regard to specifics that go from leveraging those things from a technical standpoint, also to less technical. I work, for example, in our diversity, equity, and inclusion team as well. So I may join in recruiting when I meet other mechanical engineers who have questions about what I do, what I like, what I don't like. And so there are several different things. Of course, each company is different, but I would also touch lastly on the research that we do have mechanical engineers that are actively working in research, which is probably one of the reasons why I joined my company, is because my grandmother was an amputee at the time, and DuPont was working with research in order to make cost-effective equipment for amputees in third world countries that did not have the resources that we have. So just to see the visibility come in the idea from design come into fruition, where we're taking design, we're taking materials, we're taking the research, and we're applying all of those things to everyday application, is what excited me about that.
Awesome. Thank you for sharing. Okay, we have one more question that's pre-selected, and then we'll get into our Q&A. So make sure y'all keep throwing them in the Q&A section. So the last question is for Rebecca and Leah. So you're both officers within the Women in Mechanical Engineering at UT. So can you talk about like how you got involved and what WME is about, and then what you're looking forward to as a leader this year?
So I got involved with student organizations as a whole just through Gonda Engineering and Gonda Texas during orientation. I really wanted to feel like I had a place at UT, and I definitely have found that within WME. I didn't realize as well just how important diversity, equity, inclusion work would be to me. And looking back on the last 3 years, I definitely have not only benefited from it, but also helped contribute to helping other women and also other engineers feel more at home within mechanical engineering and at UT, which is something I'm really grateful I had the opportunity to do. That was honestly the primary reason why I decided to become an officer for WME, and I'm very glad that I did. We're all about just having a place for women to be themselves. Oftentimes you hear the stereotypes of what an engineer looks like, and we're actively trying to fight against that just by being here, taking a stand and helping each other get through what is for anyone 4 years of very difficult coursework. Helping each other navigate what happens after graduation, what that looks like, because even for me, I'm about to head into my 4th year. I'm still pretty scared about what that looks like, but I have a game plan, also partially thanks to who I met in WME. We do various social events, corporate events, volunteering, go out and picnic, and looking forward to definitely hosting those events once again in person next year.
Yeah, I got involved in WME because the Women in Engineering program also has like a PAL program. So I was paired with an upperclassman in mechanical engineering who was an officer in WME at the time, and she really encouraged me to come out. And it's been an awesome experience. And I'm going to be the outreach officer, so I'm in charge of a lot of volunteer work and reaching out to younger people in the community, because we want everyone who could be involved or excited about mechanical engineering to be here. And I have to second everything Rebecca said, and I think part of our club is, right, like I know I wouldn't be in mechanical engineering without opportunities I found as a kid through the Girl Scouts, where they really empowered me, that not everyone has. And I think now that we're adults and we have mentors and everything, but the club is about being those uplifters for each other and ourselves as we go through this. And, you know, it's just an awesome time. We, as she said, all these things, and we like to do crafts. And I think I really felt like I belonged when we were talking in a group, and there was more people than I've ever met in my life who all knew how to make macarons. And I was like, wow, this is my place too. And it's just awesome to make those sorts of connections with other women in mechanical engineering, and super fun and really empowering.
Awesome. Okay, so now I'm going to hand it over to Jane, who will get us started with our Q&A.
All right. Thanks everybody for sending in your questions. Keep sending them as we do this. When upvote the ones that you want to get answered. I'll start it off with this one. I really could be open to anybody. What does a job in mechanical engineering look like? And I assume that this person means like the day-to-day tasks that you're doing. Is it very hands-on, or is it different from what you might expect, or like the stereotypical picture of a mechanical engineer that we talked about earlier?
So I can answer or start off answering that question. And first, I will put out a disclaimer and say that I recommend any engineering student to get intern and co-op experience before obtaining a full-time position. So I can speak to the day-to-day mechanical engineering role as well as a consultant role. So first, from a manufacturing perspective, a mechanical engineer would first, when they get up in the morning, they go to the site, and the first thing is a morning meeting. Usually the morning meeting is the rack up meeting where they discuss everything that is going on at the plant that day, what's running well, what's not running well, if the plan changed or if it's going as planned. And then of course the mechanical engineer is going to have some work derived from that discussion and from the events that happened the night before or the day before. In that, there would be some collaboration with maintenance, with mechanics on items that are working well, things that may not be designed correctly. They may have to give input on specific equipment issues or opportunities for improvement. And then I would also say that it comes into the perspective of every mechanical engineer is going to have critical operating tasks for that year. So the business has set up plans with that, the plans that the site, the location, the manufacturing facility has derives from that business goal. That site plan derived from the business goal is now going to be infiltrated into the personal goal of that mechanical engineer. So everything that you would do within that year time frame would be necessarily toward that site and business goal. In the site mechanical engineering role is more hands-on. And I would say that there are different things that you can do even as a site mechanical engineer. There are maintenance engineers, there are process engineers that are more deemed towards like a run plant engineer, they would be called. And then there are reliability engineers. So the maintenance engineer would be the technical resource that does the day-to-day work, working with the mechanics of the assets. The run plant engineer would be day-to-day on understanding the upsets. They're working more with operations for that facility. And then the last one would be that those resources for reliability engineering would be more predictive, more proactive. So if I've had 5 failures in the past, I can pretty much do a data analysis and tell you when it's going to fail again. And so I'm going to help you develop a plan to mitigate us having upsets when that failure does happen, or replace and repair before that does happen. From the consultant perspective, which is why I work in, my day can go from 10 meetings in one day to one meeting in one day where I'm controlling my schedule. It depends on what's going on. So I support around 11 sites in North America for the average of my time. Then I work on corporate tasks in regard to diversity, in regard to our reliability metrics and maintenance metrics as a whole, and then corporate initiatives when it comes to engineering as well as safety. So all of those things give me a conglomerate of, I may be talking about one subject on Tuesday at 8 a.m. and I've probably talked about 7 subjects by the time that day closes. And I have to revert back to the first thing that I was talking about in a couple of days. So it takes much organization. It depends on what facet that you're working in. I will say that it's best to ask those questions in regard to the organization that you choose to commit to on what that day looks like, because every company is going to be different in regard to the culture, the expectation, and the contributions and scope of what you'll be doing.
Excellent. Thank you, LaJoya. And I agree with that very last bit. Asking a recruiter or something, what does an average day look like, is an excellent way to get a more realistic sense of what you'd be doing. Wonderful. Let's move on to our next one. Again, this could be open to anybody, but a student perspective might be interesting. Do you recommend majoring in something kind of broad like mechanical engineering instead of something like biomedical engineering to keep your options more open? Just a disclaimer, all engineering is very broad, so no matter what, you will have a very broad basis going in, but I'll let the panelists take over.
Yeah. So that's actually the reason why I came into mechanical engineering, because all the applications in which I wanted to do like product design and industrial engineering did fall under the mechanical engineering department. But if you already know for certain that you want to go into something more specific like biomedical, and at some point you change your mind, there's still definitely different avenues within each engineering to get to where you want to go. I would think of your degree as more of a tool rather than what defines your life. I was just talking to, right, I should preface, I'm currently interning with Nike as a footwear product creation intern, and they have a lot of panelists that also come and talk to the interns, and one of them yesterday described their role as VP of like footwear product development, but he had an English literature degree. So really kind of shows no matter where you start, you can change the world.
All right, great answer. This next question also for Rebecca, because you're going into your 4th year. Congratulations, almost there. Where do you see yourself at the end of your degree? Where would you like to work, or what kinds of projects would you like to do? Is Nike in your future long term? Let us know.
Yeah. So I am really excited. I definitely at this point in time would love to go back to Nike for sure. I've interned at the Department of Transportation before interning at Nike, so it kind of gave me a depth in what a mechanical engineer can do. But I'm definitely, because of my experiences in projects, I didn't want to go into a lot of depth beforehand, but I've worked on a lot of different projects again to further my mechanical engineering experience in aerospace, in pharmacy, in energy, and I also worked as a mechanic for a little while as well, to see how much I wanted to get hands-on experience. And I think the role that I ideally find myself in is a materials and design related role, that allows me to see my product or service, whichever I design, to from start ideation to the end of recommend getting involved, but also balancing that with health, both physical and mental, while you're here.
Awesome. All right, so this is going to be our last question. We're running a little short on time, so we don't have a ton of time to answer it. But for each of you, what is one thing that has been fantastic about your experience pursuing your engineering degree or career?
I'll start off. So I would say what has been exciting for me was first to be able to attend a class for each discipline. So I had a chemical engineering class, electrical, civil, and I learned so much from each of those. I had a material science class as well. And I remember in my civil engineering class, the civil professor, he actually worked for the city, and he explained to us, he said, I hope you know that you will never get paid enough for what you do. He said that the value of our work is so much more broad than this salary amount. And a lot of times, it's easy to lose that perspective and to understand that we work for our community. We work for the safety of our culture and those principles that we integrate into our studies, into our execution, into our morals and ethics are the height of those values. And he shared a story about design when he said that in some countries, they would have engineers design, for example, a civil engineer would design a bridge and they opened it up. When they opened the bridge that day, they would have the design team stand and their family stand under the bridge. That was to ensure that they designed it with the most passion as possible because they cared about their family members being subject to any effects of that design. And so that was an intense, explanation that he gave us, but I'll never forget it because I've known so many people that have been beneficiaries of engineering, like we are beneficiaries of engineering. Mostly everything that we see has had engineering to it in some way, shape, or form that it has touched. And so I like to see things tangibly come from the ideal phase to actually being able to touch it and see it bless others and help others. So that's exciting for me, that it's not just a concept, but we affect and impact the world in so many different facets.
Okay. How about Leah? Would you like to go next?
Yeah, sure. I mean, kind of going off of that, it is really exciting to know that you're working on something that is going to help your community and others. And what's also really exciting to me so far about being in engineering is kind of this realization that, like, we're working on building solutions, right? Like in my negative emissions technology, it's really an emerging technology and we're finding something new that hasn't been done before. And we're really discovering and building something, in my opinion. And that's really exciting to me. And then, yeah, and here you're surrounded by other students and there's just kind of like a flurry of excitement, even just like plain school projects, because people are excited to learn and design and build. And it's a great energy to be a part of.
Awesome.
Yeah. I can go next. So one thing that's been fantastic about my experience pursuing engineering is just the people that I get to meet and the ideas that get produced from it. There's really nothing else in this world like coming up with some idea, putting it on like a notebook or a napkin, and then seeing that through all the way to the end. That feeling of just like bringing something that you are so passionate about into the world is a huge driver as to why I do engineering. And the people I get to meet along the way definitely support that. And I know that I can call a lot of the people I've met in mechanical engineering as friends that I will have for life. So that's another thing.
Awesome. All right. So that is going to be the conclusion of our panel today. Thank you to our fabulous panelists, and thanks everyone for joining today.